Hey, this is Josh, and welcome to a new series I'm making just all about tricks for dealing with fractions. Today I'm going to show you guys how I like to approach simplifying fractions, and it pretty much comes down to just, well, taking your time. So for this lesson, I'm going to assume you know the basics for simplifying fractions. For example, if we have something just like something like 3 over 6, for example, you could take a common factor of each of these two numbers, in this case 3. You can divide both the top and the bottom by 3, the numerator and the denominator by 3, and we would end up with a simplified fraction of 1 over 2. So a very general example. I just need to make sure that you know how to do that. And yeah, today I'm just going to be talking about how you can just take your time with this and just some things to look out for. So when it comes to simplifying fractions, to me, there's a big 4 when it comes to what factors to use or what factors to look out for. And those 4 numbers to really watch out for are dividing by 2, dividing by 3, dividing by 5, and also dividing by 10. Now, I included 10 just because it's a really easy one to catch. But technically, if a number is divisible by both 2 and 5, it's also divisible by 10. But you'll see in a second why I have that one up there. And of course, there's other factors that can be out there, but these are 4 really common ones, especially 2 and 3. Those are 2 that you should always be looking out for, because there are some tricks you can do to know if 2 numbers are divisible by 2 or 3, or even 5 or 10. So I just have some random fractions up there just to show you what I mean for some of these. So the first one is being divisible by 2. So if a number ends in a 0, a 2, a 4, a 6, or an 8, I have no idea why I have 10 up there. But I guess technically, but that's just a typo that I'm not gonna get rid of. So you can see on this first fraction here, 68 over 74. Right away, you can see that both fractions end in an even number. This one ends in an 8, and this one ends in a 4. So even if you're looking really hard at that fraction and you don't know where to start, a good starting point would be 2. And that's the thing about simplifying fractions. You don't have to simplify by the biggest number right off the bat. The whole point of this is to just take your time. 68 divided by 2 will get you 34. And 74 divided by 2, that should get you 37. That is actually as simplified as this fraction can get. But even if it wasn't, that's okay. You can take your time, okay? You simplify by 1, see if you can do it again after. But this works just fine for that one. So the next one I'm going to talk about is being divisible by 3. Now, this is one that a lot of people don't know, so I'm really glad I can bring this up in this video. If the sum of the digits of a number is in the 3 times table, then the number itself is divisible by 3. If you have no idea what that means, I'll show you in a second. So I've got 603 divided by, or 603 over 714, okay? Now, if I were just to look at the digits of that top number, 6 plus 0 plus 3. I'm just doing a little side calculation here. If you add those 3 numbers up, you get 9. And it's important to note that 9 is in the 3 times table. Let's take a look at the other one. So we have 7 plus 1 plus 4. Again, this is just a little side calculation we're doing. 7 plus 1 is 8. 8 plus 4 is 12. Both 9 and 12 are in the 3 times table, which tells us both of these numbers are divisible by 3. So if you don't know where to start with a crazy number like that, you can do something like this and see if 3 works, because 3 is kind of a tough number to catch sometimes when simplifying fractions. So yeah, we could just simplify this by 3. 603 divided by 3 is 201. And then as for that bottom one, you know I can do that with long division, but just to save some time, I'm going to do this on a calculator. 238 is what I got. I'm not going to continue to try simplifying that. That might actually be as far as we can go. that would get us 13 in the denominator if we added those up. So anyways, that one you might be able to simplify more, but not with any of these easy ones. But I'm going to move on. Now the last two I'm going to talk about are really easy to catch. Being divisible by 5 and being divisible by 10. So if a number ends in a 5 or a 0, or in this case a 0 or a 5, the number is divisible by 5. So right off the bat, 75 over 90, both of those numbers end in either a 0 or a 5. So we know we can simplify these both by a factor of 5, which is really nice. 75 divided by 5 is 15. And 90 divided by 5 is 18. And we could actually keep going with this if we wanted. Both 15 and 18 are in the 3 times table, so we could simplify these both by 3 if we wanted to keep going. You will see that will actually come up in the next one as well. Spoiler alert. I end up with 5 over 6 for that one, so yeah. Okay, and same thing with 10. If a number ends in a 0, it's divisible by 10. And what's great about this is you don't even really have to think too hard. If they both end in a 0, you can literally just chop off the 0 at the end for both of them. So 810 over 1500 can right away be simplified to 81 over 150, right off the bat. So if you see a 0 in the top, you see a 0 in the bottom, you can just do that right away. It's a pretty sweet little trick. And also, check this out. 8 plus 1 is 9. 1 plus 5 plus 0 is 6. Both of these numbers are actually divisible by 3 as well. So we could keep this going if we wanted, which we should, because we should always simplify our fractions fully if we can. 81 divided by 3 is 27. And 150 divided by 3 is just 50. And I think that's as far as we can go on that one. Yeah, we can't actually simplify that any farther, so that would be our final answer for that one. I'm going to show you guys one more, and then we'll wrap it up for today. So the whole point of today is just understanding that you can take your time with simplifying fractions. So the last one I'm going to talk about today is 900 over 1020. Now, let's say you're really, really good at this stuff and you can tell right away that these two numbers are actually divisible by 60. Then you can go ahead and do that. That's totally fine. But the point is, you don't need to jump right to the biggest possible number right off the bat. You can get the same answer just by taking your time. So 900 divided by 60 is 15. And this is a really weird calculation. 1020 divided by 60 is actually 17. I know this because I made up these numbers for this problem. But check this out. You don't need to do it all at once. If we have 900 over 1020, let's get this problem set up again. Let's just go back over our rules that we talked about earlier, and see if we can fix this up a little bit right off the bat. So right away, we can see both of these numbers end in a 0. So let's make our lives a lot easier and just divide these both by 10 right away. Or as I like to do, just to get rid of the 0 right away. So now we have 90 over 102. A lot easier to work with. And there's actually a few things we can do from here. We can see that both these numbers are actually even. So let's divide by 2. And seriously, 2 should be your go-to, all right? It should be your go-to. If both numbers are even, you can do 2 right away. 2 should always be the first one that comes to mind. So let's do that. So we'll divide them both by 2 because they're both even. 90 divided by 2 is 45. And 102 divided by 2 is 51. Okay. Let's check if these are both even, because, again, that would be a good one to do if we can. But 45 is not even, and neither is 51, so, okay, we can't do 2. But what about 3? Well, 4 plus 5 is 9, and 5 plus 1 is 6. Both of those numbers are in the 3 times table, so we can actually divide these both by 3. So 45 divided by 3 and 51 divided by 3. 51 is one of those numbers that looks like it should be prime, but it's actually in the 3 times table. If we work this out, 45 divided by 3 is 15, and 51 divided by 3 is actually 17. So that it kind of explains why 51 is kind of weird, because 17 is kind of a weird number too. And check this out. We got the exact same answer as we did if we divided by the greatest common factor right off the bat. Doesn't matter. You can take your time. Just take your time. That's the biggest piece of advice I can give you on this today. One final thing as well. I noticed some of our lessons in my courses, they have cases where you can simplify along the way. Like if we have like 2 over 4 times, I don't know, 10 over 18. And you can start canceling out common factors at this step and do all of that before you work it out. But you totally don't have to. You can just multiply these two numbers out. I think that's 72. I really hope I'm right on that. And then you can simplify it at the end, okay? You don't have to do the simplifying throughout if you think it's too confusing. I wouldn't even do that. I like simplifying at the very end. I think that's a good habit to get into. But don't forget, you can take your time when you're simplifying. So I hope this video helped. And yeah, thanks for watching.